Hi students, welcome back to 8th English medium science class. Today we will start a new lesson, that is light. The world is largely known through the senses. So how we interact with the world? How do you understand the world? You understand the world by senses. We have 5 sense organs. In that most important is eye. Eyes can see the world, the sensation of sight, and then nose can understand the smell, that is sensation of the smell, and ears can hear the sound, so hearing is also a sensation, and then tongue helps in identifying the taste, and skin helps in identifying the changes in temperature and pressure outside. So in this way, the senses are important to understand the outer world. If we don't have senses, we cannot see the world or imagine the world. The sense of light is one of the most important senses. The sense of sight. If you can't see anything, you cannot see the world, and it is very difficult for the life. Through it we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. Everything appears to us because of the sense of sight. We also see clouds, rainbows, and birds flying in the sky. And at night we see the moon and stars. And you are able to see the words and sentences printed in the book. So everything we can see, from a amoeba bacteria through microscope you can see, and you can also see the largest mountain with your eyes. You can see planets, you can see stars. So sense of sight is very important to see the world. And how these things appear? What makes things visible? How the things are visible to our eyes? So have you ever thought how we see various objects? You may say that eyes see the objects, but can you see an object in the dark? Not possible. Our eyes can see the objects, but only in the light, not in dark. If the current goes off, or during the night, when current goes off, immediately you cannot see anything. So you will light a candle or you will light a torch, and then you will be able to see the objects. So when light is present, you can see the objects. It is only when light from an object enters our eyes that we see the objects. So only when light from an object enters our eyes that we see the objects. Eyes alone cannot see any object. It is only when light from the object enters our eyes we can see the object. The light may have been emitted by the object. So some objects emit the light themselves. For example, stars. Stars are sending the light, that's why we can see the stars. And moon is sending the light towards earth, that's why we can see the moon. Or may have been reflected by it. So stars are sending the light themselves, but moon is reflecting the light from the sun, so we can see the moon. Similarly, if the bulb is emitting the light, we can see the bulb, and that light falls on the table reflects the light, and we can see the table. You learnt in 7th class that a polished or shiny surface can act as mirror. You can see your face in the mirror, or a new plate, steel plate, which is having very shining shape. You can see your image. That shows that any polished surface can act as mirror. A mirror changes the direction of light that falls on it. So after falling on the mirror and reflecting back, it changes the direction of the light. Can you tell in which direction the light falls on a surface will be reflected? So in which direction the light travels, we are going to study here after the reflection. They are laws of reflection. So there is an activity given. Fix a white sheet of paper on drawing board or a table. Take a comb and close all its openings except one in the middle. You can use a strip of black paper for this purpose. Hold the comb perpendicular to the sheet of the paper. Throw light from a torch through the opening of the comb from one side. With a slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Keep the comb and torch steady. Place a strip of plain mirror in the path of the ray. What do you observe? So you can also take a laser lights are available nowadays. So using laser light, you can insert the light on a mirror and see in which direction the light reflects. After striking the mirror, the ray of light is reflected in another direction. So after striking the mirror, if this is the mirror and you send the ray of light, it will fall on the mirror and go in another direction. So it is reflecting in another direction. The light ray which strikes any surface is called as incident ray. The light ray which strikes any surface is called as incident ray. The ray that comes back from the surface after reflection is known as reflected ray. So based on the terminology, so you can say that when light ray falls on the mirror, so this ray is called as incident ray. Incident ray. So when it reflects back, that ray can be called as reflected ray. Reflected ray, second one. So here a ray of light is an idealization. Idealization means representation. In reality, we have a narrow beam of light which is made up of several rays. So single ray you cannot see with your eyes, because single ray is very small. The ray which we say, it is nothing but bundle of so many rays. It is called as beam of light. Bundle of so many light rays we call as beam of light. For simplicity, we use the term ray for narrow beam of light. So for simplicity or for understanding, we take beam of light as a ray. Now draw lines showing the position of the plane mirror, the incident ray and the reflected ray on the paper with the help of your friends. So in which path the light is traveling, you draw the line and you draw the mirror also. And remove the mirror and comb. Now draw a line making an angle of 90 degree to the line representing the mirror at the point where the incident ray strikes the mirror. This line is known as normal. So here you can see the incident ray, reflected ray, and this central line is called as normal. It is drawn 90 degree to the plane mirror, to the reflecting surface at the point. The angle between normal and incident ray is called as angle of incidence. So this angle between the incident ray and normal is called as incident angle or angle of incidence and denoted by letter I. The angle between the normal and the reflected ray is known as the angle of reflection. The angle between normal and reflected ray is called as angle of reflection. So measure the angle of incidence and angle of reflection using the protractor and repeat the activity for several times by changing the angle of incidence. So you incident the light in different angles and calculate what is the angle of reflection and what is the angle of incidence and make a table. Enter data in the table 16.1 like this. So you will find that if angle of incidence is 50 degree, angle of reflection will also be 50 degree. If it is 30 degree, it will be also 30 degree. If you take 100 degree, it will be 100 degree. So in this way, you will find angle of incidence will be always equal to angle of reflection. So do you see any relation between the angle of incidence and angle of reflection? They are approximately equal. If the experiment is carried out carefully, it is seen that angle of incidence is always equal to the angle of reflection. This is first law of reflection. So this is first law of reflection. So let us perform another activity on the reflection. So you perform activity 16 point again, 1 again. This time use a sheet of stiff paper or a chart paper. Let the sheet project a little beyond the edge of the table. Cut the projecting portion of the sheet in the middle. Look at the reflected ray. Make sure that reflected ray extends to the projected portion of the paper. Bend that part of the projected portion on which reflected ray falls. So can you still see the reflected ray? Bring the paper back to the original position. Can you see the reflected ray again? What do you infer? So here incident ray, reflected ray and normal at the point of incidence lie on the same plane. So you will not see the ray of light when you fold the paper. When the whole sheet of paper is spread on the table, it represents one plane. It is one plane. The incident ray, the normal at the point of incidence and reflected ray are all in this plane. So they are all moving in the same plane. You change the plane, they are not available. When you bend the paper, you create a plane of different from the plane in which the incident ray and the normal lie. Then you do not see the reflected ray. So if you change the plane or if you fold the paper and reflect the light, you will not see the light because they always lie on the same plane. So this indicates that the incident ray, the normal at the point of incidence and reflected ray all lie in the same plane. So this is second law of reflection. Paheli and Bujo performed the above activities outside the classroom with the sun as the source of light instead of torch. So you too can use the sun as the source of light and you will get the same result. These activities can also be performed by making use of ray strike apparatus available in the kit prepared by NCERT. And Buzo remembered that in class 7th he had studied some features of the image of an object formed by a plane mirror. So Paheli asked him to recall those features. Was the image erect or upside down? So if you see the image in the mirror, is it straight or upside down? It is always erect. If you stand in front of the mirror, say this is the mirror, and you will stand here, you will see the image like this. So this is called as erect image. Head is up and legs are down. What is of the size of the image and object? So it is same size of the object. Did the image appear at the same distance? Yes. So how much long you are standing in front of the mirror, the same distance it is behind the mirror. And can you hold it on the screen? Can you take your image on the wall like projector? No, it is not possible. So let us understand more about the information of an image by plane mirror. So here an activity is explained. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it. So can you find out the direction of reflected rays? Draw normals to the surface of the mirror PQ at the point A and C. So here from O, two rays of light are coming and they are falling on A and C, and two perpendiculars are drawn on that, and angle of incidence is equal to angle of reflection. So you can draw the refracted results. Call the reflected rays AB and CD respectively and extend them further. Do they meet? Extend them backwards. Do they meet now? So if you extend them in this direction, they will never meet. But if you extend them backward, they will meet in some place. The rays, we mark this point as I. They will be meeting on the another side. For a viewer's eye at E, do the reflected rays appear to come from the point I? Yes. Since the reflected rays do not actually meet at I, but only appear to do so, we say that virtual image of the point O is formed at O. So we see the image of point O at the eye. So it is called as virtual image, false image, which is behind the mirror. We say that virtual image of point O is formed at eye. As you have learnt already in class 7, such an image cannot be obtained on screen. So you cannot obtain this image on the screen, so it is called as virtual image. You may recall that an image formed by a mirror, the left of the object appears on the right and the right of the object appears on left. This is known as lateral inversion. The image formed by a mirror, the left of the object appears right in the mirror and the right appears on the left in the mirror. This is known as lateral inversion. If you raise your right hand, the image raises its left hand. If you raise your left hand, the image raises its right hand. Therefore, such type of change is called as internal inversion. In next session, we will learn more about the reflection. So until that, you read the lesson and write the notes. Thank you.
It's so dark. I can't see anything.
Here you go.
Why do you think Tina couldn't see anything in the dark, even with her eyes open? Clearly, just the eyes are not enough to see. We can see only when light emitted by or reflected from an object enters our eyes. In this lesson, you will learn about reflection of light in plane mirrors and multiple reflections. At the end of this lesson, you will be able to identify the laws of reflection, identify the characteristics of images formed in plane mirrors, differentiate between diffused and regular reflection, explain how reflected light can be reflected again, and demonstrate that sunlight is formed of several colors.
Hey, Tina, look here.
Ouch! What are you doing? Stop that!
James has figured out a way to direct sun rays towards Tina and is having fun teasing her. Hey James, Tina.
Hey.
I see you're having a good time.
Yeah, this mirror game is cool.
Sure it is. However, do you know that this game uses the phenomenon reflection of light?
Well, I can definitely see he's using sunlight to tease me. So, what exactly is reflection of light?
The bouncing back of light incident on an object into the same medium through which it is incident on the object is called reflection of light.
Bouncing back of light?
Sounds confusing? Well, let me start from the basics. You are aware that light travels in straight lines, right?
Yes, we learned that in school.
The path along which light travels is called a ray of light. A ray of light is generally represented by a directed line segment. A collection of light rays is called a beam of light.
So, James was directing a beam of sunlight at me?
Yes, he was able to direct the beam using the laws of reflection. Light rays follow two laws of reflection. They are: the angle of incidence is always equal to the angle of reflection. The incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. However, that's a lot of jargon. Let's carry out an activity to understand the basic terms related to reflection and then prove the first law of reflection. We will need a plane mirror, a torch, a cardboard with a very narrow rectangular slit, white sheets of paper, pencil, adhesive tape, a protractor, and a set square.
There you go.
Good. Let's start with our activity. First, we fix the white sheet of paper on a table with the adhesive tape, so that a portion of the paper protrudes outside the table. We fix the cardboard on this sheet of paper. Then, we place the lit torch on the table and adjust it in such a way that the streak of light from the rectangular slit is seen along the white paper. The rectangular slit should be at the center of the light beam from the torch. Finally, we place a small strip of mirror in the path of the light ray. So, what do you see?
The light ray strikes the mirror and reflects in another direction.
Right. Something like what you were doing in your game. The light ray from the source of the reflecting surface is called the incident ray.
So in this case, The light ray from the torch hitting the mirror is the incident ray.
That's right. The light ray that bounces off the reflecting surface in another direction is called the reflected ray.
Are you referring to the ray that is reflected back from the mirror?
Exactly. Let's continue with our activity. Now, we draw a line on the paper along the mirror to mark its position. We mark some points on the path of the incident ray from the torch to the mirror. Similarly, we mark the path of the reflected ray. Now, let's remove the torch, cardboard and mirror and join the points. Can you see where these lines intersect?
Interesting. The lines drawn along the paths of the incident and the reflected light rays intersect at a point on the line we drew to indicate the plane mirror.
The point at which the incident ray strikes the reflecting surface is called the point of incidence. Next, we draw a perpendicular to the line representing the mirror at the point of incidence by using the set square. This line is called the normal. Can you see how the other lines form angles with the normal?
Yes, both the reflected ray and the incident ray form angles with the normal.
The angle between the incident ray and the normal is called the angle of incidence. It is represented by the letter I. The angle between the reflected ray and the normal is called the angle of reflection. It is represented by the letter R. Now compare the angle of incidence and the angle of reflection using a protractor. Which one seems bigger?
Neither. Both angles seem to measure the same.
Correct. That's because the angle of incidence is always equal to the angle of reflection. Now let's look at the second law, which states the incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. We will slightly modify the setup that we used in the previous activity. Consider the portion of the white paper that extends beyond the edge of the table. Initially, you can see that the reflected light rays are on this portion of the paper, right?
Right. Now, fold the paper downwards along the edge of the table. What do you observe? Can you see the reflected light ray on the portion of the paper that has been folded downward?
No, it is not visible now.
This is because the bent portion of the paper is now in a different plane. That is, the vertical plane. Thus, the plane of the reflected ray is different from that of the incident ray.
I get it. When the paper was spread straight along the surface of the table, it was on the same plane as that of the light ray incident on the mirror. The incident ray, reflected ray, and the normal, all the three were in the same plane. When the paper was folded, it went to a different plane, and so the reflected ray was not visible on that part of the paper. So that was the secret behind the trick James was playing on me?
Yes. Now that you know the laws, you can explore them and create tricks of your own. Tina is getting ready to go out. Hey, Tina, all set to go?
Yes, James and I need to decide on a project on reflection in plane mirrors. We have a lot of reading up to do.
Well, try observing your own image to begin with.
What do you mean?
When you look into the mirror, is your image erect or upside down?
Erect of course.
How about the size of your image?
Looks the same size as me. Also, at the same distance from the mirror.
Yes, that's right. You could depict these properties of images in your science project. I'll give you an example. Let's take the letter R and see how its image is formed in a plane mirror. Place the letter in front of a mirror. We can treat this as an object. We know that light from objects reflects from the mirror. Consider a point X on top of the object and a point Y at the bottom of the object. Let MN represent the surface of the mirror. From point X on the object, consider a light ray incident on the mirror at point A. According to the laws of reflection, the angle of incidence is always equal to the angle of reflection. Observe the angle of the incident ray as it reflects and travels to the eye of the observer. From the same point X on the object, another light ray is incident on the mirror at point B, and the reflected ray travels to the eye. The two reflected rays from A and B are divergent. When extended behind the mirror, these rays meet at X dash. Thus, the image of the point X on the object is formed at X dash. Consider one more point Y on the object. A light ray from Y on the object is incident on the mirror at C, and the reflected ray travels to the eye. Similarly, another ray from Y on the object is incident on the mirror at D and is reflected to travel to the eye. Like the two reflected rays from A and B, the two reflected rays from C and D are divergent too, and when extended behind the mirror, meet at Y dash. Thus, Y dash is the image of point Y on the object.
That's a lot of rays.
Yes. It takes a large number of light rays to form a reflection of an object. So, as you can see, rays from all points on an object are incident on the mirror and reflected in different directions. That is, the reflected rays are divergent.
So, how do they form an image?
All these divergent rays are extended behind the mirror to form a complete image of the object.
So, the image is formed behind the mirror?
Yes. That's why images formed by a plane mirror cannot be obtained on a screen. Now let me show you another interesting thing about images in plane mirrors. Raise your right hand.
Okay, sure.
What does the mirror show you? Which hand is raised?
Oh, I see what you mean. In the mirror, it looks like the left hand.
Now, observe the image of the letter R formed during the activity.
Same thing, the left side appears to be on the right, and the right side appears to be on the left.
That is because of the phenomenon of lateral inversion. The image of an object that you see in a plane mirror is laterally inverted.
Hey, I can see my image in the window pane too.
Yes, the laws of reflection apply to all surfaces.
But then, why can't I see my reflection on other surfaces, like a wall for instance?
That's because light rays incident on surfaces like a wall are parallel, but the reflected rays are not. This happens because the surface of the wall is irregular. The reflection from such irregular surfaces is called irregular or diffused reflection. The reflection from a very smooth surface, like that of a plain mirror or a plain glass, is called regular reflection. In regular reflection, a set of incident rays parallel to each other is reflected from a very smooth surface as another set of parallel rays.
Are you saying that images are not formed on irregular surfaces?
That's correct. Images are formed due to regular reflections. Therefore, you are able to see your image in the window pane and the mirror, but not on the wall.
Are we able to see the stars and other objects in the sky due to reflection?
Yes, not all bodies have light of their own. Some bodies are visible only because they receive light from other objects and reflect it. Objects that have light of their own are called luminous objects, and others that don't are called illuminated objects. For example, the sun, a lit candle, and a glowing bulb are luminous bodies, while the moon, a table, and a book are illuminated objects.
Tina is fascinated with the mirrored walls. She can see so many Tinas, she can't even count them.
Hey, Tina, I have a surprise for you.
A kaleidoscope. That's so cool. Look at all those beautiful patterns.
Aren't you curious about how all those lovely patterns are formed?
Is it due to reflection of light?
Well, yes. But a kaleidoscope goes a step further. It works on the principle of multiple reflections.
Oh, how's that?
Well, you can see innumerable reflections of yourself in these mirrored walls, right? A kaleidoscope utilizes the same phenomenon. Multiple images are a result of multiple reflections. That is, light rays are reflected many times across a set of mirrors. Some other examples of multiple reflections are found in mirror maze, saloon, periscope.
I'd sure like to see how my kaleidoscope works.
Well, let me show you through an activity. Let's take two plain mirrors and fix them in such a way that their edges form an angle of 90 degrees. Now place a small shell between the mirrors. What do you observe?
I can see a total of 4 shells.
Yes, one is the shell and the other 3 are its images. That's a result of multiple reflections across 2 mirrors.
But why only 3 images this time?
The number of images depends on the angle between the mirrors. The greater the angle between the mirrors, the lesser the number of images formed. Therefore, infinite images are formed when mirrors are kept parallel. Now let's see how this works in a kaleidoscope. You need 3 rectangular strips of mirror, each around 20 centimeters in length and 5 centimeters wide, a circular cardboard, a circular piece of ground glass, a plain glass disc, adhesive tape, chart paper, and some pieces of small colored glass.
Okay, we've got everything. Now what?
Join the 3 strips of mirror to form a triangle and fix them using the adhesive tape. Fix the mirrors into a circular tube made from the chart paper. Close one end of the tube with a cardboard disc which has a hole in the middle. Paste a transparent paper on the disc. Invert the circular tube. On the other end, fix the plain glass disc and put colored pieces on it. Then, close the end with the ground glass. The glass pieces should be small enough to move between the plane and the ground glass discs. Now, look through the hole on the cardboard disc.
Oh wow! It works! I can see so many colorful patterns every time I turn the tube. Hey, it's drizzling! And look, a rainbow! Isn't it beautiful?
Yes, the formation of a rainbow is a natural phenomenon. It occurs due to the dispersion of light. You know that sunlight, which is white, consists of 7 colors.
Yes, I know. We refer to the colors in the rainbow as Vibgyor.
That's right. We can reproduce a rainbow by passing a beam of light through a prism. You'll learn more about rainbows and dispersion of light in higher classes. This brings you to the end of this lesson on reflection in plane mirrors. In this lesson, you learned to identify the laws of reflection, identify the characteristic of images formed in plane mirrors, differentiate between diffused and regular reflection, explain how a reflected light ray can be reflected again, and demonstrate that sunlight is formed of several colors.